Welcome, 8th grade. Today we're talking about real numbers. All right, this will be the second lesson of the day. You'll have the video. You'll kind of do it on your own with real numbers. We can practice these. Remember the square root. All right, we have getting that not exactly to that 10 point whatever it is, but knowing that, 10 times 10 is 100, 11 times 11 is 121. So we know it's between 10 and 11. With 15, doing the same thing, knowing it's between -4 and -3. The only reason they're negative is because this is out here. Because remember, you can't have a negative square root. And then using a calculator, we showed you how to do that, where you actually get that decimal to double check. All right. So today, for the rest of the day, learn to determine if a number is a rational or irrational number. All right. We've got these. Biologists classify animals based on shared characteristics. The cardinal is an animal, a vertebrate, a bird, and a passerine. So it fits into all these categories. Down at that lowest level, into the passerine group. You already know that some numbers can be classified as whole numbers, integers, or rational numbers. Now, recall that a rational number can be written as fractions. Rational numbers can also be written as decimals that either terminate or repeat. Okay? Irrational numbers is a small group, but they are a group. They can only be written as decimals that do not terminate, like pi or like square root of 2. They go on forever and ever and ever, never repeating. All right? These are irrational numbers because we cannot get to the end of them. We cannot answer them as a question. All right? A repeating decimal may not appear to repeat on a calculator because calculators show a finite number of digits. So it only goes so far that it stops. That's what finite means. So be careful there. Now, think of this as all the numbers in the world. If you think of this real number box, the real numbers are all the numbers in the world. Okay? Now, within these, if we have a number like 1, I circled it, 1 is a natural number. Well, the natural number is inside the whole number, so 1 is a whole number. 1 is an integer. 1 is a rational number. And 1 is a real number. So the further down in the circles you are, the more of these categories you fit into. Notice also, if we look at the irrational numbers, they're separated from the rational numbers at first. Okay? So we have to figure out which category they fit into. And then, like if we got 1, then we have to go to each next category up until we've covered them all. Now, if it was something like just 0, 0 would be a whole number, an integer, a rational number, and a real number, but not a natural number. Okay? That's how that chart works. Figure out where your number goes, which circle, and then you keep counting out for every circle outside of that. So, write all the names that apply to each number. So if we look back, and I'm going to suggest having your books out when you do this, so a square root of 5, you would want to put that in your calculator. Square root of 5, does it come out? Is a whole number that is not a perfect square, so that's an irrational. So if it's not a perfect square, we're going to call it irrational. And then it's real, because if we put it in the irrational, it's also a real number because it's inside that blue square. All right? So every number is a real number, whether it's irrational or rational, and we move on. All right? So perfect squares or not perfect squares, they are irrational numbers. -12.75. So -12.75, that is a decimal. All right, it's not a whole number. So we would probably put that first in that group of rational numbers because it's a decimal that's terminating, and then real numbers. Okay, that chart's going to be helpful. Find out which group it goes into, and then you can go out. This one, square root of 16. Square root of 16 is 4. 4 divided by 2 is 2. 2 is that littlest group. It's in that smallest circle. It's in the whole numbers, and then the integer, then the rational numbers, then the real numbers. It includes all of the groups. All right. Again, now we look at 9. Square root of 9. With the square root of 9, we know that's 3. 3 goes down to that smallest group. So we start with the whole numbers and we work our way out. -35.9. That doesn't fit in until we get to the real numbers, the rational numbers, and then it's included in the real numbers as well. That chart will be helpful. You want to use it. Oh, negative 35.9. Oh, that fits in by these that have that terminating decimal. Then you go to the other ones outside there. All right, square root of 81 over 3. Well, that 81, the square root of it is 9. 9 divided by 3, all right, is 3. So, hey, that goes all the way down to whole numbers, and we work our whole way out. Whole numbers, integer, rational, and reals. State if each number is rational, irrational, or not a real number. Okay? State if each number is rational, irrational, or not a real number. This not a real number, if you put it into your calculator and it says error, it's not a real number. Square root of 21 is an irrational number because it is not a perfect square. 0 divided by 3 is 0. So that is a rational number. All right. Now they're not asking us to go all the way down and do that. If we did, we would have gone down to not whole number, but the next one up, and then gone upward. Okay. Here. Now, there's no way in the world that if we look at this negative that's right there, all right, there's no way in this world that if we got this negative number, we can have any two numbers that will multiply to get negative 4. So that is not a real number. If you would put that in your calculator with the negative 4 and then do the square root sign, it would go, not possible. This one is 2/3. So it's a fraction, so that is a real number. Or a rational number, excuse me, a rational number. Then, with this, square root of 23, not a perfect square, so that goes to the irrational numbers, okay? Now, 9 divided by 0. If you put 9 divided by 0, anything divided by 0 is undefined, so this is not a real number even, all right? It's an undefined, so not a real number. So two things that will get you into not a real number. Trying to take the square root of a negative or dividing by 0. All right, again, we have another one of these. So C, not a real number. Can't have that negative sign under there. This one, square root of 64 is 8. Square root of 81 is 9. 8/9. Oh, that is a rational number because it is a fraction. Okay. The density property of real numbers states that between any two real numbers is another real number. This property is also true for rational numbers, but not for whole numbers or integers. For instance, there are no integers between -2 and -3. But if we're doing rational numbers, if we are doing rational numbers, we can always make it a smaller number. 2.1, 2.2. It doesn't seem like there could be any number between that, but there's actually an infinite number. I could have 2.11, 2.12, 2.13. Oh. And even between 2.11 and 2.12, I could have more sets there. Oh, I could go 2.111, 2.112. Oh. By adding that place value to the right with decimals or rational numbers, we can always put numbers between each other. All right? So find a real number between 3 2/5 and 3 3/5. All right? So my suggestion is just expand the fractions. 2 over 2, you get 4/10. All right? 2 over 2, you get 3 6/10. Oh, so I can see my number that goes between is 3 5/10. All right? We expanded the fraction, and we found a number that would fit between there. All right? So they did their work. All right? And they look at this. They see that there's a number between there. I would simply expand the fraction and find what you can put between there. Okay? Now, here again, they both have the 7. It doesn't look like there's anything there. I always just use the simplest one, 2 over 2. So 4 6/14. This would be, if I use 2 over 2, because just a fancy one, 8/14. hey, then I can realize, oh, 4 and 7/16. All right, fits between there. Okay. Notice I keep them, even though they could be reduced, I keep them as numbers there. That helps me see what can go between. They'll show you their method. They add them together, divide by 2, and they get 4.5. All right. So that's what we put in there. All right. But I think it is much, much easier if we do it my way. Maybe I'm not right there, but because 7/14. Remember we had 4 and 7/14. I think I wrote 16ths, but that is 4.5. I just believe my way is easier. You are able to use their way of adding them together and dividing by 2. I have no problem with that. Thank you all for your time. I'll get that loaded up for you.